Welcome again to JS Physics, and in today's video we will be using the instrument to find unknown resistance by using Wheatstone's bridge. If you have not seen my previous video, you can just click on the link given in the description box. So let us begin. Wheatstone's bridge. What is Wheatstone's bridge? Let us understand. Basically, Wheatstone's bridge is a device which consists of four resistances connected to form four sides of the quadrilateral. In one diagonal, galvanometer is connected, and in the other diagonal, battery and plug key are connected. Let us see the diagram. This is typical of Wheatstone's bridge. Now here you can see there are four branches. Total five branches are there. A, B, C, D. This is a quadrilateral in which one branch AB contains resistance P, BC branch contains resistance Q, the third branch contains S, and fourth branch contains R resistance. So basically four resistances are connected to form four sides of the quadrilateral. One diagonal, that is BD, contains galvanometer, and the second diagonal, that is AC, contains a cell or battery and plug key connected to that. Now we can see that the current starts flowing from positive of the battery, and the value of the current is I. When it comes at point I, which is a electrical junction as per our Kirchhoff's law, the current gets divided into two parts. One part of the current flows in AB branch, that we'll call I1, and the second part of the current will flow in AD branch, that we'll call I2. So this current moves in the forward direction again, and the current I1 at point B is again divided into two. The current in the branch BD, where galvanometer is connected, is IG. So the rest of the current, that is I1 minus IG, will pass through BC branch. At the same time, at point D, current I2 and IG will combine to give you I2 plus IG in branch R. So that is how distribution of the current is there in a Wheatstone's bridge. Let us analyze its theory. Again, this is the same circuit. Now, here we have two junctions, A and C. So if we apply our Kirchhoff's law at junction A or C, we can get current I is equal to I1 plus I2. So using Kirchhoff's law, we are getting I is I1 plus I2. Now, here if we apply the same Kirchhoff's law, second Kirchhoff's law, to loop A, B, D, A and B, C, D, B, then we can get equations like this. Suppose if I take A, B, D, A, then I will get minus I1 into P, that is product of current and resistance. Then along BD branch, minus IG into G plus I2 into S, and the sum of this will be 0 as per the second Kirchhoff's law. Similarly, if we apply it to the branch BC or loop BCDB, then along the branch BC, the current is I1 minus IG. So I1 minus IG into Q plus, now here the current is coming opposite to us. We are moving in the clockwise. It is coming in the opposite direction. So it is plus I2 plus IG into R plus IG into G, that is equal to 0. That means two independent loops we have taken and we have applied Kirchhoff's law as our previous video. Now the Wheatstone's bridge is said to be balanced if the current through the branch BD or galvanometer is 0. Then the Wheatstone's bridge is said to be balanced bridge. So if the bridge is balanced, that means Ig is equal to 0. So in both these two equations, I'll place the value of Ig is equal to 0 and I'll get I1 into P is equal to I2 into S. And from second equation, I'll get I1Q is equal to I2 into R. If I divide these two equations, I'll get P by Q is equal to S by R. That means the ratio of resistance P and Q is equal to ratio of resistance S and R. And this is nothing but balancing condition of the Wheatstone's bridge. And this condition is very useful to determine unknown resistance if we know three resistances in a given Wheatstone's bridge. So P by Q is S by R. If I know three resistances, I can calculate the fourth one. So that is how we can find out value of unknown resistance, provided if we know the value of three resistances in a Wheatstone's bridge. Now let us do one activity. You will read the question, pause the video, check the answer. Let us start. Find the value of X if there is no current through branch BD. Now the circuit is given to us. Again, A, B, C, D, A. This quadrilateral is there. AB branch contains 16 ohms, BC 4 ohms, AD 40 and 40 ohms in parallel, whereas CD branch contains value of resistance as X. So we have to find how much resistance we have to connect as X in CD branch. That is our question. So solve this question and check your answer. Here is the answer. You should get 5 ohms. How come? 40 and 40 ohms resistances are in parallel, and that is connected in AD branch of the network. That means if you calculate the effective resistance of 40 and 40 in parallel, your answer will come out to be 20, right? And that 20 is connected across AD. That means now you can apply our condition of balanced Wheatstone's bridge. So you can write 16 by 4 is equal to Rp by X, where Rp is equal to effective of 40 and 40 in parallel. So by simple calculation, you'll be able to get the answer of 5 ohms. So this is the application or calculation done by using Wheatstone's bridge. So our next topic will be applications of the Wheatstone's bridge. In the next video, we'll discuss the applications of Wheatstone's bridge. Thank you.